So we've been spending all of this time looking, finding the derivative, finding the slope of, of a function at a certain point. For example, we just did in the last video with implicit differentiation. We were looking for, the slope of the tangent at the point on some point of a circle, right? Now, what we also can do is, quite simply, is we can find the normal line, and what that is, that's just the line that's perpendicular to the tangent line at any point, or that's coming straight out of the circle, right? It could be coming out this way or this way, instead of finding the tangent. And how we do that, we'll just write that here. So the slope of the normal line, we'll write that here, we'll say m normal is going to be equal to -1 over the slope of the tangent line, right? It is perpendicular, it's just the negative reciprocal of the tangent. So let's do an example. Let's do another implicit differentiation example. We don't have to do this, we don't have to, it doesn't have to be a circle, it could just be a function. Anything that has a slope, we can find the normal slope of it. But let's see, let's do this, say x to the 2/3 plus y to the 2/3 is equal to 6. So what we want to do, we want to find, this is some form of a circle, right? I don't know where the circle is, or how big it is, but we want to find out, we're going to know that this is touching the point 8, 1. So we want to find the normal right here at, -8 and 1. Okay, so what we want to do is we want to differentiate this. We'll start with this term. We'll bring the 2/3 down. We'll get 2/3 x to the power of 1/3, right? 2/3 minus 1. Then we'll get plus, now we're going to differentiate this term. So we'll get 2/3 y, 2/3 y to the power of 1/3. Now we're differentiating with respect to x, so when we multiply times the derivative of x, this is gonna be times 1, right? This is like the chain rule. We'll do the outside of x times the inside of x, but the derivative of x is just 1. Now when we do that with y, we don't know what y is. So when we multiply the outside of it, we get 2/3 x, or 2/3 y to the power of 1/3. And when we multiply times the derivative of the inside, that's just going to be times y prime. We're not sure what that is yet. Now, we're going to differentiate the 6, and we'll get this equal to 0. And then we'll just rearrange this. We'll have y prime on one side. And we'll have this is equal to, let's see, -2/3 x to the power of 1/3 over, now we'll divide it by this, 2/3 y to the power of 1/3. And we can cancel out this 2/3 with this 2/3, and we're left with, we could say the cube root of x over the cube root of y. So now what we want to do is we want to find y prime at the points -8 and 1. So if this is y prime, all we have to do is just put in the points, -8 and 1. We'll write it like this: y prime, we'll say at the point, -8, 1. This isn't really proper notation. This is just so you guys know that we're solving for that point. So what do we get? We'll have the negative cube root of x is -8, and this is over the cube root of y, which is just 1. So the cube root of -8 is -2 over 1, or just -2. So that's what the slope is at this point. Now, what we want to do is we want to find the tangent line, right? We have the slope. This is like, if we have y is equal to mx plus b, we just have m. But we want to find the entire equation for this line. So what we're going to do is we're going to put this in, we're going to use the point slope form of a line, which is written like this: y minus y1, minus y1 is equal to m times x minus x1. Right, that's just the point and slope form of a line. Now we know that y1, we're going to use these points, so y1 is going to be equal to 1, and our slope we found is equal to -2, and x1 we're going to say is equal to -8, but it's minus -8, so we'll have plus 8. Alright, so now let's just rearrange a little bit and we can isolate for y. So we'll have y is equal to -2x minus 16 plus 1. So y is equal to, we'd have -2x minus 15, just to not confuse anyone. This here is the tangent. Here, sorry, this is the tangent. Right, so its y-intercept is minus 15 and its slope is -2. So now what we want to do is we wanted to solve for what the normal is. And so the normal slope, the slope of the normal line, right, is the negative reciprocal of the slope of the tangent line. So we can use, and we're using the same points, so we can rewrite this equation again, but switch out the slope for the normal slope, and then we'll find out what the equation of that line is. So again, we'll say y minus y1 is equal to m times x minus x1. Alright, and so now we're going to use the same points, so we'll have y minus 1 is equal to m times this x plus 8. And now the negative reciprocal of -2, if you just put in -2 here, it's just going to be positive 1/2. Right? So we'll go through this again and we get, well, y minus 1 will be equal to 1/2 x plus 4, 1/2 x plus 4. So y will be equal to 1/2 x plus 5. Alright, so there you go. This is the equation here of the normal line. I'll write that here. Normal. Oops. There we go. So that's how you do it. We did this using implicit differentiation. You can do it on any graph. You can do it on a cubic or a quadratic, whatever you want. So once you understand finding tangent lines, finding the normal is just as easy.